Hey everyone, let's take a look at number 5 in section 8.2. In this one, we're going to compute the surface area of the solid of revolution that's being formed by rotating uh, the region that's bounded by, of course, the x-axis and the curve y equal 5x cubed over the interval from 0 to 2 about the x-axis. Not going to draw this out, what the graph of 5x cubed looks like on the interval from 0 to 2. At 0, it's 0. And at 2, it's going to be 5 times 840. So you've got that shape that's going to rotate around, and we're looking at the exposed surface on the curve. As that curve rotates about the x-axis, it forms a three-dimensional solid, and we're looking at the surface area of that. Okay, so from that, remember we derived this formula for the surface area, 2 pi, of course the integral from a to b, in this case going from 0 to 2, of the function times the derivative squared plus 1 under the radical. So this really comes from the arc length, and the 2 pi times f of x is kind of like the circumference as we rotate that thing about, and we talked about how that made sense when we derived this. At any rate, we can now compute this by taking the derivative of 5x cubed. I'll let that be f of x. The derivative is 15x squared, and so our derivative squared, 15x squared squared, is 225x to the fourth. So this is what I'm integrating. F of x is 5x cubed, 1 plus the derivative squared. I'm going to do a little substitution, obviously, change of variables to evaluate this definite integral. I'm going to let u be the stuff under the radical. So what's the derivative of that? Bring, of course, derivative of 1 is 0. Bring the 4 down. I get 900x cubed. So du is 900x cubed dx. If I divide by 900 on both sides, I get this. And I'll just go ahead, since I've got a 5 here, I'll multiply by 5. 5 over 900 is 1 over 180 simplified down du. So I'm going to replace the 5x squared dx with the 1 over 180 du. Of course, this will be the square root of u, or u to the 1/2. And then I do want to change the limit since I'm going over to u, right? When x is 0, if I plug in 0 here, u is just 1. When x is 2, I get u is 225 times 2 to the fourth. Well, plugging it into our calculator, we get 3,601. All right, so now I've got the 2 pi out here still. The 1 over 80 du, I'll pull that 1 over 80 out. So I got 2 pi over 180 du. The square root of all this stuff is u to the 1/2. And then again, I change the limits, right? 0 is now 1, and the upper limit of 2 is now 3,601. So we now can find the antiderivative by the power rule. The antiderivative of u to the 1/2 is 2/3 u to the 3/2. Simplify that 2 over 180 to 1 over 90. So I've got pi over 90 here. And then I can notice that I can simplify this part. 2/3 times pi over 90. 2 goes into 90 45 times. 45 times 3 is 135. So pull that out, the constant multiple, and then it's just u to the 3/2 evaluated at 3,601, and then evaluated at 1. And I think this is fine. I think they wanted a symbolic exact answer. Again, you could rewrite 3,601 to the 3/2 powers as 3,601 times the square root of 3,601. But again, this is fine. And you can use your calculator to approximate this if you need to, but this is the exact answer that they want for this problem. Hopefully this helps.